All right, so I'll repeat that again for the recording. I guess I'll introduce myself. I'm Mark Powers. I'm the DevOps lead for Chameleon. And before I pass it off to Kate to introduce Chameleon a bit, if you've never used Chameleon and you want to try things out, you can go to this URL. It'll ask you to make an account. And you can do that by just clicking sign in with your institution credentials here. Or if you have a Google or Orchid, that works as well if your institution is not a part of this group. And then you'll see the screen to request to join the tutorials project. Click confirm, and I'll get those requests.
If you're sitting there, they can't see you. You might want to go this way.
Okay.
Yeah. Sorry, I didn't mention that.
Camera.
The camera doesn't see that far.
I'll move over to the center.
Okay.
Okay. So now they can all see you very well.
Okay. And that's where I'll stop this for now. And I'll monitor those requests. And I'm going to pass it off to Kate to introduce everything.
Yes, I want to share this. And I think I was right.
Yes.
Okay. All right. My name is Kate Keahey. Mark already introduced himself. We're both from the Chameleon project. I'm the Chameleon PI. Mark is the Chameleon DevOps lead. So what we'd like to do in this hackathon is introduce everybody to Chameleon. First of all, explain a little bit the role that infrastructure or very importantly, open infrastructure can play in supporting practical reproducibility. And then, I'll sort of explain, I'll do a dry talk and explain how we're thinking about it and what services we're providing to promote it. And some of those services are related to Chameleon, some of them are open to other testbeds as well. And then Mark will go over and show you what all of this looks like in practice. So you, in fact, will be hearing about the same material twice. Once the theory behind it, and then the second time, how to actually do it yourself. And then Mark will also demonstrate an experiment that you could reproduce from Chameleon, a very, very simple one. I believe it's the power management one that you were going to do.
Yes.
And then we've got a list of experiments that you could reproduce, including an experiment from a paper that was presented at this conference. So you could reproduce that experiment, as well as some suggestions on experiments that you may want to package. So for the rest of the hackathon, you'll be applying this knowledge from Mark's presentation and mine in either reproducing or packaging new experiments. Then, of course, we'd love if you could talk to us and make suggestions and ask questions and tell us where those things work for you and where they don't. Okay, so to dive into a little bit of background to Chameleon, for those of you who already are familiar with Chameleon, you can skip. I will get a new attendee here.
Yeah, certainly.
Was going over how to create Chameleon accounts or how to log into Chameleon. Have you done that before?
No.
If you could join the Zoom, I can send it in chat. Wow.
Okay. Right. A quick overview of Chameleon. It's an experimental testbed for computer science. So actually, before I jump into Chameleon, I just want to say a few words about what the practical reproducibility in my title is, right? So what we're trying to do is make reproducibility much more a mainstream, everyday kind of activity than it is right now. Right now, reproducibility in computer science research anyways is mostly confined, not entirely, but generally confined to various artifact evaluation initiatives when people are trying to make experiments available, reproduce them, but it's not used in the mainstream. It's not used by individual investigators, when they are entering a new area, it's still the coin of the realm is to read papers. And so we'd like to change that modus operandi. We would like science to be much more interactive and people to explore science in more interactive ways. And test beds or open platforms on which research are done are fundamental to it. So I'll tell you a little bit about that testbed called Chameleon. There will be an opportunity also to talk about some other testbeds that are supporting different types of computer science research. So one thing that we emphasize in Chameleon is to cover a wide range of hardware, from large to small. So the two foundational resources or foundational sites of Chameleon are University of Chicago TAC. In both cases, the hardware is part of a large supercomputing center. TAC is the Texas Advanced Computing Center. The University of Chicago hardware is at the ALCF, the Advanced Leadership Computing Facility machine room at Argonne. They are both top 10 supercomputing centers and have a lot of experience in managing scale. They're also connected by a 100G network, which allows people to do experiments with large flows, and hopefully that will get upgraded soon to something even more capable. But we also, on the other end of the spectrum, seek to support edge devices. So single board computers like Raspberry Pis or NVIDIA Nanos, which are increasingly more popular today because they allow investigators to instrument their environment for all sorts of reasons. Right, so we put those devices in the field where they are collocated with phenomena that they want to observe and measure, right? So they want to understand, for example, the quality of access networks, or they want to look at wildlife patterns or intelligent agriculture and things like that. So the hardware is also very diverse. We've got multiple types of FPGAs, many different types of accelerators, including very capable ones, but also gaming GPUs like RTXs. We've got a range of different storage, memory, infrastructure, from consumer grade to enterprise grade NVMEs, SSDs, all sorts of different types that you can compare and contrast the performance of. We've got NVDIMMs, interesting networking hardware, and so on and so forth. And we also packaged the Chameleon infrastructure to make it easy to install. The packaging is called Chinabox. And it's not just packaging of the system, but it also packages the operations model. And that made it easy for multiple different sites to join Chameleon. So Chameleon right now has a site at the Illinois Institute of Technology, at NCAR, which is another supercomputing center. So NCAR donated some very interesting Thunder nodes that they were using to test their future supercomputer. We've got sites at Northwestern and UIC as well, and are working with multiple other institutions to configure Chameleon volunteer sites. And that, of course, gives the system not only more computing, and more interesting computing, but it also gives us a higher degree of distribution, right? So if you want to run very distributed experiments, that's a much better platform. So a lot of interesting hardware, distributed hardware, very diverse, all sorts of things. The second thing to know about Chameleon is that, of course, Chameleons like to change, right? So the name of our system derives from the fact that we try to adapt ourselves to whatever configuration you need for your experimental needs, right? And for that, we support bare metal reconfigurability. So by far, most of Chameleon, most of the system is configured to support bare metal reconfiguration. So you could change the firmware, you can power the nodes on and off, reboot them, boot from custom kernel, and all sorts of things like that. And the reason for support for bare metal reconfigurability is that many computer science experiments need that, right? So people who experiment with performance variability, especially with hardware variability, need that. Power management is another type of experiments that it's a branch of science that is very, very popular today, obviously very important. Also is something that requires experimental configuration, but not everybody does. So for folks who don't do that, and generally speaking, those are educational projects, we also support a KVM cloud. So it's a small part of Chameleon resources has been virtualized and supports a virtualized cloud. And for edge computing, I said we could add edge devices to Chameleon and work with them. We support the configuration via containers. So there are different types of reconfiguration that we support for different types of hardware and in different situations. And all of that means that you have a broader range of experiments that you can run and reproduce. And last but not least, Chameleon is slightly unusual in the sense that it was based on mainstream infrastructure. So typically, test beds for computer science research were configured using something developed in-house, because it's really a venture that goes on and on, right? The test bed is a scientific instrument, which means that it has to adapt and change as people find new research questions to answer. And for that, people always felt that they needed to develop something customized. We took a different approach. We said, well, most of the functionality that we want to provide is really provided by OpenStack with bare metal reconfigurability. So we just need to add some of our own special sauce, and we figure it's about 50% of the system is that special sauce. This is what science needs. And that special sauce includes special network features, snapshotting, integration with Jupyter, which I'll talk about some later on, and generally speaking, special features for experimentation. So in addition to all this, we have a service called Trovi that I'll talk about a little bit more in a bit. And we also support Chameleon daypass, which is something that allows you as the owner of an experiment, the author of an experiment, to give access to the testbed to others, right? So Chameleon is available for research. Anybody who wants to do research can use the system. And there are various policy loopholes that sometimes make it a little bit difficult to get access, for example, if you're coming from industry. Right? So we emphasize participation from academia and places like that. So this can be create a little bit of friction if you're trying to get access. So you can just go to author, and the author can give you access from a special reproducibility allocation under the Chameleon daypass. And all of this, so this means that absolutely anyone in the world could reproduce your experiment. Right? It is in your purview to give them access to reproduce your experiment. And like I already mentioned, we've got all packaged so that if you want to add a site, you can add a site. And this actually proved to be a reasonably important feature, because in HPC and other communities that do research on architecture, it's sometimes very difficult to get access to hardware, to very unique hardware. So if you have the system packaged, you can add such hardware easily for a limited period of time. And that makes it available to, again, anyone in the world for reproducibility. So if you need hardware to reproduce things, we try to make it possible for you to get it. A few numbers about Chameleon. We went online in July of 2015, so almost 8 years now. In those 8 years, we had the privilege to serve over 8,000 users coming from many countries and many institutions. We've got almost 1,000 projects. I think we're like 13 projects shy of 1,000 unique projects. Now, in Chameleon, many users, they submit a project, a research project, in order to get access to the resources, in order to get an allocation, and then they just keep renewing that project, right? We don't count renewals in this number, we just count unique projects. And this community published more than 600 papers that we know about. Right, that we were able to find. Our users, like they said, we used Chameleon for this paper, and we went through the attestation cycle, or we found it from other sources where they explicitly cited Chameleon. So this number is a lower bound. I'm sure there's more papers that use Chameleon out there, but those are the ones that we were able to find. A quick overview of Chameleon hardware. Like I said, we've got two sites, one at the University of Chicago, the other one at TAC. At University of Chicago, we also have the capability to add G@Edge devices. And we've got some G@Edge devices that are available in our IoT lab, but what our users prefer to do is they generally like to have their own edge devices that are connected to some camera, watching wildlife or some other sensors, and then run edge-to-cloud experiments on that added edge device, right? So maybe they use our GPU resources for training some inference models that they later on run on their edge device. So we support that functionality as well. But if you're just interested in experimenting with the edge devices, we've got a bunch of Raspberry Pis and Nanos that you could start using right away without needing to have your own. And like I said, the sites are connected via a 100G network. We've got some volunteer sites that I already talked about. And you see there's a Purdue logo, which is grayed out right now. Purdue was added on an ephemeral basis to Chameleon last year, specifically to support NSF, which is a very prestigious supercomputing competition. This year, they are running this competition again, and they are adding a supercomputer at Colorado. So it's possible to add resources to Chameleon for experimentation or reproducibility purposes for a short amount of time. And then, of course, we partner with other test beds. So there's a test bed called Fabric for networking research. They allow you to reconfigure your network at the core, which is a new capability. There is another NSF project called CloudBank, which provides access to commercial clouds. So you can run experiments across Chameleon and commercial clouds if that's what you want to do. One of those experiments is packaged on Trovi, actually. And there are also wireless test beds under the umbrella of our PAWR initiative. So there are 4 such test beds, and they provide capabilities for wireless experimentation. And we partner with all of those test beds and as much as possible encourage and support our users in running cross-platform experiments. So what does the experimental workflow look like in Chameleon? Most of the time, our users start by discovering resources. So they have some hypothesis. If your hypothesis is in machine learning, you probably need some GPUs to allocate. So you can go to our portal, look at the resources. Mark will demonstrate that later on. You can decide which resources you want to find and which will be the most suitable ones for your experiment. We version the testbed. In other words, every time we have more resources, we create a new Chameleon version, and that's again for reproducibility, because if the resources change or get upgraded in some way, that might make a difference in the results as people try to replicate them. You can allocate those resources on demand. You can also allocate them by advanced reservations, right? So especially if you want GPUs, if you come to Chameleon, it's very unlikely, especially for the sort of higher end GPUs, that they will be available on demand. Maybe RTXs might be available on demand, but you can always make an advanced reservation. So you can see when people stop using that coveted A100 GPU, and you can make a reservation for that sometime in the future. Or if you have a demo or a paper deadline and you know you're going to be using resources at a certain time, you can make an advanced reservation. And so long as that reservation is accepted, that resource is yours for that period of time, right? So there's no uncertainty there. You can make reservations in this way, not just for the nodes, but also for networks. So you can reserve VLANs. There are some, we call them stitchable VLANs, which for network stitching, for creating network slices. And you can reserve also public IPs, right? So public IPs in IPv4 space are a very scarce resource. And again, if you need a demo, or if you're going to be running a service on Chameleon and you need to give somebody that IP address ahead of time, it's a useful feature to use. We treat resources as non-fungible entities. And what does that mean? That means that if you want to say something generic, like I want an isolate node, or I want an ARM node, we will find you and we will match you to isolate node and ARM node. But we do also recognize that no two isolate nodes are the same. They can have different properties, and especially, again, if you're experimenting with systems and with low-level properties with power management and performance variability, it might make a difference to you if you're using this isolate or that isolate, right? So we do have actually users who want to use a special node to keep to the same performance baseline that is specific to a node, right? So we just treat the hardware as non-fungible. So again, you can reserve a specific node, or you can reserve by node type, and then we'll pick one node for you. We'll optimize operations. For configuration, I already said we support mainly bare metal. Most of Chameleon is available via bare metal configuration, but we also have KVM cloud and controls for the edge. We have an image catalog, so every month we publish a tips and tricks blog that highlights certain features of the system. This month's tips and tricks blog is about images and the images we support and why do we support them and what to expect and things like that. So read the blog if you want to understand more, but there's a wide range of images that we support for different hardware capabilities. We support snapshotting, which means you can save your image. So if you deploy your image, you put some extra configuration on it, and then you want to save it, that's what snapshotting is. If you want to orchestrate your experiment, in other words, do some work up front and then deploy it all with one click, right? We support something called Heat that allows you to do that via an orchestration template. And so you say, I want these 5 nodes, and this is how they're going to be connected. And when they wake up, this is what should be run on it, and things like that. So Heat orchestration will do it for you. But orchestration is declarative, and I'll talk about that a little bit more. These days, and for some time, our users have been preferring to use Chameleon via programmatic, imperative programmatic interface in Python or in Bash. They also like Jupyter notebooks. So what we did is we integrated Jupyter with Chameleon, and you can use Chameleon via programmatic, imperative programmatic interface through Jupyter notebooks. And then Mark will demonstrate and show you exactly what this looks like. We also support network stitching and bring your own controller functionality. Now, all these interfaces here that I outlined that you use at various stages in constructing your experiments are available via graphical user interface, of course, via the GUI, via command line interface, and via Python. Right, so command line interface and Python are both programmatic interfaces that support reproducibility, because of course, if you use the GUI, you never remember what you clicked on, versus when you've written a program or a script, somebody else can rerun that. And there is a paper that we have that describes all of those features in more detail and what the update was on Chameleon. And this is just a quick reminder. The testbed is not just a testbed, but it's a community of researchers. There's a lot of people behind that testbed who are using that testbed for a variety of experiments. So we collected a bunch of pictures of our users over the years, and they are presenting at conferences, showing demos, participating in competitions. They are working in their labs on a variety of different projects. We've got even a pair of RU students receiving an award at Supercomputing 2017. So if you want to understand more about what our users do, there are 2 avenues to do that. One is we have a blog, and at the bottom there's a link to, in that blog, we have a category for user experiments. So every month, we do a virtual interview with one of our users, either on education or on research stories. And they tell us about their research and how they use Chameleon. They have pointers to their papers and sometimes to the Jupyter notebooks that they use with Chameleon that you can have seen some ideas from. So those are very popular. Those are very popular content on our blog, probably the most popular stories. And the other way to find out what the users do on Chameleon is, of course, to go to our webpage, and in the About tab, you can look at the research done on Chameleon, and that's where the 613 papers are. After last count, we update it annually, generally speaking. So, okay, so much by way of introduction to Chameleon, and now switching gears a little bit, let's talk about reproducibility. So, what we realized at some point that having an open platform like Chameleon that is available to all who want to do research creates an opportunity, because that means that it takes out a barrier to reproducibility. Right? If you had an experiment, you just showing code that went into creating that experiment, that doesn't mean that it will be easy for somebody to rerun it, because the hardware on which to rerun it is a critical ingredient. And very often it's much more critical for computer science than other sciences, because for computer science, it might require a very special, unique architecture or a very special, unique networking configuration that is hard to obtain in places. So this idea that you have an open platform means that all of a sudden that obstacle to reproducibility is gone, and anybody can do it, right? So again, you can rerun experiments very easily. And what is the opportunity here? Well, one opportunity, of course, is that you're reading a paper and you see an interesting looking experiment of power management, as in this paper specifically, right? And you click on that experiment, or you tap on that graph, and you say, oh gosh, this is a very interesting graph. I wonder, what was the worst case instead of average case? Or, can I see the data, like Torsten was saying in his keynote, right? Don't show me the analytics, just show me the data. And you want to go back to the source, well, you can tap on it, you can go back to data and code that is available on an open platform, and you can redo the analytics. And you can also redo the experiment itself. And you can even redo the experimental setup, right? So you have various grades of reproducing the experiments that are suddenly available to you. And we could go even further than that. So, when I start a new area of research these days, I go to the ACM Digital Library and I say, let's see who did research on edge computing. And I read some papers and I understand what people did on edge computing or reproducibility or things like that. But I could go to another hub, a different hub, and instead of looking at papers, I could look at results. I could look at experiments that people have run. And I could download those experiments and I could run them myself, and I could reproduce them, but I could also vary them a little bit. I could say, oh, this is a great idea, but let's see how it does in this other hardware. Why didn't they run it on this other hardware? I'm gonna try that. Or I'm going to run something slightly different. I came up with a new algorithm. I'm going to drop it right beside their algorithm and compare side by side. Let's see what happens. Or they have a great model. Let's see how it does on my data set, right? Not their data set. Or I could go to the analytics and redo the analytics and play with data differently. So all of a sudden I can really interact, I can really debate and engage with the authors of that experiment much more effectively than if I'm just reading and second guessing what they must have done that generated all those great graphs. And furthermore, I could not only do that, but I could use that for teaching, right? So teaching is much easier, much more fun, I think, if you get to explore things in practice and interactively. So there are all these applications of reproducibility, and infrastructure availability is really fundamental to that, right? Because that really,
I just have a question whether I love this idea in general. Are you suggesting that from the paper, you'll be able to click on a graph and get to all these things, or there would be another sort of repository for results?
Well, I'm suggesting both, but from the paper, this paper that you're seeing there, it actually has that click in it. So this is what Mark's going to be showing, and Mark, I don't know if you have the PDF of that. This is a kind of a dummy paper that we created for a relatively simple power management experiment that would have been done maybe 30 years ago or something like that. Maybe we should go and dig for a specific paper and make it a little bit more realistic. But the PDF that we created for this, you can actually click through. So that's one thing. But the other thing is, yes, I am suggesting that there will be a hub where you come and you just have experiments that are linked to papers, right? And you can read the papers with the experiments as you explore the experiments. But in a sense, this makes the experiment a first-class citizen, right? Because right now we go to ACM Digital Library, right? We find the papers, and then we try to find some artifacts and things like that. And you know, maybe that happens, maybe that doesn't, right? Whereas what we could do is invert this process, start playing with experiments, say, geez, this is a really exciting experiment. Let's see what the author had to say about it, right? So in this conference, and in many conferences on reproducibility, what we hear is that paper is an advertisement for an experiment, right? What does that mean? That means that maybe we can skip the advertising. We can go to the actual experiment and they'll look at the advertisement a little bit too, right? Because people have interesting insights. But that, yes, you know, I'm saying maybe we've done enough advertising, right? Let's go down to this. Okay, so this idea that open platforms are critical for reproducibility because they significantly reduce friction for reproducibility is something that I tried to develop in an editorial I wrote some time ago. But essentially, what I was saying there is that we're halfway there. Without having done anything, we're essentially halfway there. Because number one, if we do have open platforms, right, then that means that you have the same access to hardware as I do. So in other words, if I do this wonderful, amazing thing and you know, evaluated it on a cluster of GPU nodes that I have in my department, so you can't reproduce it because you don't have access to the cluster of GPUs in my department. Well, now that's not the case anymore, right? We both have access to a cluster of GPU nodes, including access to the same ones, right? So again, if we do any of that low-level stuff, performance variability and things like that, we can compare head to head. We can compare things exactly. So this non-fungible resources, very important. And then open and version control also important. The other point is that if you use clouds as opposed to your laptop or any other sort of resources that somebody maybe configured for you or that you configured yourself in the hardware, you are forced to formalize part of your experiment already because you're forced to create an image to deploy on the cloud. That's just how clouds work, right? Nobody is making that up, right? This is now very different than if you experiment in a lab on a machine that was perhaps created by where the configuration was created by a system administrator, and perhaps you don't even know completely what's in that configuration, right? Because you don't necessarily know how it was created, right? So you're working with an image, with a configuration that you created yourself, and furthermore, that creation, that image is snapshotted, and it represents, or you know, or perhaps you have scripts on how that image gets created. But that snapshotting, the image plus the scripts, they represent a method for creating your experimental environment, right? So they already capture the experiment done. And here's the interesting thing. Over the last 8 years, our thousands of users created thousands of such images and orchestration templates and Jupyter notebooks. So they created all those artifacts and they are there. Most of them are actually publicly available. But even though it means that they take you halfway towards being able to reproduce an experiment, you won't find out about them. They are not connected to experiments. So there's like a treasure trove, right? It's just not connected, not advertised, not articulated. This is something that you could use for repeating that experiment. So what do we need to now find that pot of gold, right? To get at the treasure that we already have. that go down as side effect of people using clouds for experimentation. So I sort of looked at the needs of people who reproduce experiments and package experiments. So I said at the end of this, as part of the hackathon, we're going to do both, and we would really welcome your thoughts on, what those considerations really are. But when you're reproducing somebody else's experiment, what do you need? Well, from the perspective of packaging, is first of all, you would like to get a complete packaging of experiment. So all the code, all the data, all the description of how the experimental configuration was created, maybe some orchestration template, or all the data analytics, all the everything, right? All the artifacts. Secondly, I already alluded, there is a difference between a declarative formulation of an experiment and imperative formulation. But declarative formulation means I describe my experiment in terms of a state that I want to achieve for that experiment. So for example, I say a virtual cluster of 8 nodes that are configured in such and such way and interconnected in a certain way, right? And the system goes out and creates that for me. And many people find that very compelling because logically, that means that lowers the barrier to creating that experiment, just makes it easier, makes it conceptually easier. Unfortunately, if you describe things in a declarative way, that description may not be very exact, right? So there may be many configurations that fit into what you describe. That's bad for reproducibility, because if somebody recreates the configuration for some reason, ends up with something slightly different, that might not be reproducible. Also, in the process of creating that configuration, you might have some side effects. You might your process might create some side effects that might also then impact reproducibility. But the biggest problem with the declarative way of representing your experiments is the fact that they are transactional. So in other words, from here and to where you get to the state you described, it's one closed transaction. It's supposed to be one closed transaction, right? Because it's supposed to be encapsulated and easy to use, right? So not just a black box, but a shrink wrap black box. And this is a problem because experiments have different stages. You create an experimental container, you run the body of the experiment, you run data analytics, and so forth. At each of those stages, you might have a new idea. You might say, I'd like to do something else. They created a cluster of 8 nodes. I'd rather create a cluster of 512 nodes and see what happens. They ran on ice legs. What if we go back a few generations of Intel and rerun this in Haskell? What happens then, right? What if we run it on some different architecture altogether? If this is all encapsulated as a shrink wrap black box, you can't do that, right? All those opportunities to vary the experiment, to interact with science are lost. So imperative, when you write a program on how to create that experiment, right? So create this cluster of 512 nodes by allocating the nodes, reconfiguring the nodes, creating network connections and so forth, offers you many more. I mean, it's a much narrower road, so it's much less possibility of uncontrolled variation, but also much more possibility for controlled variation, right? So if you get a brilliant idea how to do things a little bit differently, you can do that. So imperative, non-transactional, right? We don't want it encapsulated. We want to be in a situation where we want to rerun it bits by bits, and there are good stopping points where you could go off in another direction. Or if something breaks, you could fix it easily, right? Because it's just a small thing that broke, right? Rather than the whole big thing broke and we don't know what to do with it. And they should be integrated. So I just said we've got those thousands of digital artifacts that are not connected to experiments and they are not connected to papers. They should be connected, right? That's what I mean by integrated. And it turns out that that integration idea has been around for a while. And of course, who else but Donald Knuth came up with it, right? And it's called literate programming. So the idea that you combine code or scientific process expressed in our case in code with explanations, with data analytics, with illustrations, and so forth. And today, the most popular implementation of literate programming is Jupyter. And I will talk about that a bit later. So secondly, the person who's reproducing this experiment, they need access to this experiment, and they need access for reproducibility, both the code and all the experimental artifacts and the infrastructure on which it is run. Right? So they then also need to discover and find experiments along the way we just talked, right? So not just from the paper, but also it would be cool to have a hub where I can go and I can say, you know, who experimented here with Edge, because I would like to look at that. So through various channels, not just through the papers. Now, from the perspective of the person who packages experiments, things are a little bit different. So especially in the packaging realm, because the author, generally speaking, in my experience at least, wants a way of packaging an experiment that is cost effective, right? So in other words, there's this dilemma. Do I put time in reproducing an experiment or making my experiment reproducible, or do I put time into new research? And making an experiment reproducible steals time away from your research. So there is that tension always. So in as much as we can make it a side effect of research or do something that users already do, that's best. And we are already doing that because we're using the cloud pattern. So people have to create images anyways to use cloud, right? We're already leveraging that, right? That happens as a side effect. Your environment gets packaged, right? So maybe we can also leverage that on other things. But they also want a way of packaging an experiment that is user-friendly because they want impact of that experiment, right? So the user-friendly brings them more in alignment with the person who is ultimately reproducing the experiment, so creates a bridge. So it's very important to preserve those author to audience incentive. So give access for reproducibility, right? Again, we're after impact. We want impact. So we want people to reproduce our experiment. So that's great. And then we want to share work in progress with collaborators, but we also want to share completed work. We want to say, this is now side of the experiment, right? And very important, get credit in some way for having packaged the experiment, for making it a contribution. So I'm going to talk, we've got services that our team developed in all three aspects of this, and I'm going to talk about them one by one, and then Mark will show you what it looks like in practice. So first of all, packaging shareable experiments. We already talked literate programming. Jupyter is a great implementation of that literate programming, and our users wanted to use Jupyter already. So what we did is we integrated, we provided a Jupyter interface to Chameleon, right? We integrated a JupyterHub with Chameleon such that when you log into JupyterHub, you log into the testbed at the same time, and your authentication, your credentials are implicit in all the Jupyter cells. This has two important, it has many consequences. It has two important ones. Number one, it just makes it easier, right? You're logged into the testbed. But number two, that also means that nowhere in that Jupyter notebook are you storing your credentials and having to take them out ultimately. So that Jupyter notebook is ready to share, right? You don't have to fiddle with any credentials. Number one, usability, very important. Number two, ready to share. It's not in the notebook. So, and then of course in Jupyter we have a Python kernel, which we already have a Python interface to the testbed, and a Bash kernel. You can use those programmatic imperative kernels, non-transactional, as an interface to the testbed. So this Jupyter notebook now acts as a glue between the various experiment artifacts that you have. So those images, those thousands of abandoned publicly available images that were not connected to a result, are now connected to a result. They're connected to the rest of the experiment, right? Because in your Jupyter notebook, you say which image you deploy, right? It captures that code. And then you can create what we call experiment patterns, which are essentially an experimental container that many people can use. So in the power management experiment that Mark is going to be demonstrating, somebody else could take the container creation, the experimental environment creation part of that Jupyter notebook, just cut and paste, create your own experiment, no control management, something completely different. Somebody could take just the data analysis part of that experiment, use that data analysis in a different experiment, right? Or replace it with your own different data analysis. You can mix and match different ways. And again, we've got a paper that explains a little bit more behind the philosophy of that combination. So this packaging, it achieves for us very important place. Again, it connects all the experimental artifacts. It lowers the barrier to experimentation somewhat. It provides a sort of, as a side effect, vehicle for our users who use Jupyter. A lot of them do, right? So it's many advantages there. So then you want those experiments to be findable, but how are they going to be findable? And this is, again, this is an area where we feel the infrastructure can help, right? Because if you think about sharing papers, we're all equipped to read papers, right? All we need is a pair of eyes to read a paper. If you share digital content, it's not so easy because you need either visualization or you need a programming environment to replay that experiment, or you need something, you need the infrastructure. Right? So sharing experiments should be, I would argue that sharing experiments should be done close to the infrastructure, especially if your experiments have a strong dependence on infrastructure, right? And the metaphor I use is that of a library, which if you check out the microphone from a library, they will also give you a microphone reader, because otherwise you can't really do anything with that microphone, right? So they need to equip you. Similarly here, if you share experimental artifacts, they need to be shared as a compute capsule, as a combination of code, data, other artifacts, and infrastructure on which those artifacts can be replayed. So we created a service called Trovi, and sometimes people refer to it as Chameleon Trovi, and we need to all fight that because this is not a Chameleon service. So Trovi has open APIs that allow you to integrate any testbed, any open platform with the Trovi system. And we're currently working with Fabric, and we're also working with another NSF-supported cloud called Jetstream to integrate them with Trovi so that users can run experiments or teaching modules or anything like that on those different platforms as well. Right, so some artifacts will be, you can run only on Fabric because they provide network capabilities that we don't provide. Like Chameleon is not a network testbed. Some artifacts will be executable only on Chameleon, right? Because Chameleon provides GPUs, which Fabric doesn't provide, right? They're a networking testbed, they're not, they don't support cloud computing research. But the important thing is that you can go to one hub and have artifacts that run on all those different testbeds. All those testbeds also support federated identity, which means that you don't have to create a special accounts for any of them. It's kind of like having a Jerome and all of those things. So Trovi has Trovi artifacts. A Trovi artifact represent an experiment, so has all those experiment components I was talking about. And what we're trying to do also in Trovi is add metrics, because that's, again, those incentives that create a bridge between the author of an experiment and somebody who uses the experiment. So metrics that tell you how many times an experiment was viewed, how many times an experiment was executed. And they're perhaps not perfect. They are, first iteration of creating some sort of incentive structure, but they're there. And we've got a portal, and we expose APIs. So our portal is maybe not the most wonderful thing in the world. We're backend people, we're not portal people, but anybody can implement any other front end, right? So long as you have the APIs. And we also integrated with Trovi, we integrated with Swift, which is the object store in Chameleon, so you can store experiments, sort of basic storage. But we also integrated with GitHub, right? So GitHub provides a lot of cool features like versioning, like the ability to fork and manage code forks and things like that. that we don't want to replicate, right? So we've got an integration with GitHub that hopefully will improve over time. And lastly, we have an integration with Zenodo. So once you feel that your experiment is ready for sharing, ready for publishing, you can publish it to Zenodo, get a DOI, then you can then reference in your paper, right? You can say in your paper, this is the DOI for the experiment, and the experiment might take on a life after your paper. People might create new versions, right? But this is one way to look at it. Okay, so much about findability, and last but not least, Chameleon daypass. So we do provide access to the testbed with daypass, and you see this paper that I was showing earlier. It will take you to the page for the experiment, and on that page you've got this request daypass button, and you can say, I'm going to ask for reproducing this experiment on Chameleon. I have no account on Chameleon, or maybe I don't want to use up my allocation on Chameleon, and then the author has the opportunity to give you access. So we've got an open platform for systems research. Just enough of this dry talk. I'm going to turn it over to Mark. Our configuration, the direct range of hardware, all of those things. And the question is, how can we use it to promote reproducibility for computer science in particular, right? How can we promote a more interactive approach to science? And we sort of propose the sort of three-pronged approach, or three-pillar approach, or however you choose to describe it, right? Via programmatic interface to the testbed, literate programming that allows you to create a link between the research and the experiment. Trovi, an experiment repository that is not just a repository of experiments, codes, artifacts, but also integrates them with an infrastructure from which they can be read, which can open possibly multiple infrastructures, but at least one, and Chameleon daypass for ephemeral access. Okay, so now we've got it, we take it over to Mark. I'm going to stop sharing, and Mark will show you how all those things look in practice.
Yes, okay. And I think as people were joining the Zoom, I was sending them my slides so they can follow along. So if anyone else wants to join the Zoom, I can. You can then click on links, but I'll also show you how to navigate around. Okay. So the first thing I want to show is if you have already followed these first two slides, and I believe I have added you to a Chameleon project, meaning you now have access to all of these resources Kate was just talking about. And if you go to our website, chameleoncloud.org, once you have that project, that allocation, you'll have a project here. It should be the tutorial project, but with that project, you can get started. And so the first thing I'd like to point out is we have this experiment tab, and there's Trovi. And this is what Kate was just talking about. This is our artifact repository of where people have published and shared experiments that work on Chameleon. And the first few things here we have are kind of featured ways to get started and show off different parts of the testbed. So this first one, bare metal experiment pattern, I'm going to open, and it's also linked in the slides there. And here it gives some description of what exactly this does, and it talks about the history. But in order to use it, there's this launch button. And as a lot of people try to do this at once, it may slow down, as this is a Kubernetes cluster, and so it's going to have to scale. But it should get you in within about a minute, I would say. Once it slows down, hopefully it goes faster for me. I've launched this before, so I expect it to look the same as what you would all be seeing. Okay, and this is the Jupyter environment that Kate was talking about. And so this is JupyterHub. And what that allows us to do is give you a Jupyter lab environment, but we authenticate you when you log in and authenticate you to the testbed resources. So the first thing I'll do is I'll open this up. And this experiment comes with a README, which talks in more detail of what exactly is going on. So the first few steps of the experiment, the first one is to set up, the first step is to set up the environment for it. So that means we're going to need a bare metal node, and this is a little small, but so we'll grab a bare metal node, and to do that on Chameleon, since we're in a shared environment, we have to reserve it first. But usually there are some on-demand resources you can grab right away. And then we'll have to actually create an instance on that bare metal node and then install any software that we need for our experiment. So I'll get that started now. And then this takes a bit of time since we're configuring bare metal servers. So here, maybe I'm going too fast through this, but I opened up the experiment file that it mentions in the README. And there is some literate text here. So the first thing we have to do is create the experiment container, as I just explained. And here it also mentions we'll give it an IP. And that'll just help us connect to it to programmatically run commands. So the first thing we have to do is configure a little bit. And that means we have to add what project we're using. So I'm a Chameleon operator. So I am a part of this Chameleon project, but everybody else that joined the tutorial project, if I go to my dashboard, my projects, and I have a lot of projects. So I just go down, there's this one, Chameleon user meeting tutorials. So I'm just reusing this from our previous meeting, but it gives us the project name, CHI 231132. So I'll copy that and paste it here as my project name. And it says I'm using this project. And I also, in this step, told it to use the University of Chicago site. And that's located in the Argonne National Lab data center. If I wanted to change site, I can update that line there. The next step in this experiment is to create the reservation. So I'm actually going to tell it what node I want to use. And this is where it explains here there's various types of errors that might occur at this step and how to get around them. But I'll hopefully run it successfully with no problems. And it has given me some helpful output. So it created a lease and now has to wait for the lease to start. And I think that should take under a minute here. Yeah. So I was able to find these resources, and now we just have to wait for them to be ready. So even though this is a lease, I was able to grab these on-demand resources. While that's running, I can talk through what's going to happen in this next step. So now, once we have the lease, we're able to actually provision the node that comes with. And if I look here, I can actually see what I reserved. So I got a node reservation, and there's this variable here for a compute Cascade Lake R. And I'll show a bit more about what that means, but that's the type of CPU on that node. And there's also this floating IP reservation, and that worked out. Okay, so now there's this provision step that I'm gonna get running, because this takes the longest. And it may take around 10 minutes. And this is because we are flashing our OS image here. So we have CC CentOS 8 stream. This is basically just CentOS 8, but we installed a few helpful utilities to access your object store data and to flash your instance. But and we load your SSH keys onto this. But that's what this is. It's basically just CentOS 8. So I think everybody who I added to the project should be able to have run this. Has anyone had issues yet? Or I don't know if people are running it, but let me check if everybody got the Zoom link. Let me okay, so showing off a bit more of what is going on. I mentioned that I was getting a Cascade Lake R node. So what exactly does that mean? That's a great question. Back on the Chameleon website, under this experiment tab, right above Trovi, well, a few items above Trovi, there's a hardware discovery button, and that'll show you all the hardware. And it took a second to load as it went through all of our various sites to gather the inventories, but it shows there's 586 nodes right now that you can use on Chameleon. These are broadly our node, this is called the node type, all these words, and we used Cascade Lake R, and it says there's 82 of those. If I click on it, I can filter and view more of what all the nodes in this category are. And I'll click on this one. So this one is C0615. It says it's at TAC, and I look at the processor, it tells me, you know, what exactly it is. It tells me what networking hardware is connected to this node, what storage devices this has exactly, and what you can expect if you reserve that node. We have given all the nodes the node type that kind of broadly group them all together, but I believe the hardware should be pretty consistent within each of these categories. Or if I don't know exactly what I want, I can go down to these advanced filters and say, well, you know, maybe I want a node that has 96 threads on the CPU. And then as I scroll down through the advanced, you know, I can filter by how much cache there is, or if I have certain experiments and I'm going to want to set up my own cluster, I'm going to want to filter by nodes in the same rack. Maybe you want to get GPUs. We have all the different GPU models here as well. We have nodes with FPGAs. We have nodes with high bandwidth network adapters, and if you're interested in specific storage types, we have all the models listed there as well. So I can go back to my tab here, and it's still going to be waiting for the server to start, which is fine. While that happens, maybe I can show you the next thing here. If I scroll up on the hardware discovery, it mentions first there's calendars for each site on what exactly their availability is. So if I click this link for Chi at UC, which is the site I was using, it'll open the calendar. And here I can see a row for each node of this type. So I switched it to Cascade Lake R. And I see all of the different nodes. Each of these colored bars is somebody is using that node. So there's lots of availability for this node type. Yeah, and if I scroll down, I think these two must be people running the bare metal experiments, as I see that they just started, or maybe that was a coincidence. Yeah, there's a few successful reservations there. If I go to like one of our GPU nodes, here's A100s, and they're all very busy. So as Kate mentioned, sometimes you have to book ahead, especially for these more in-demand nodes, but I think the RTX nodes, it looks like there's at least one that is open right now. The other way to get to that is sometimes when you log in, it redirects you. On the left here, there's a reservations tab, and leases, and then the calendar. And while I guess I am still waiting for my server to start, I'd like to also show a bit more of this GUI interface.
Can I just ask a naive question?
Yeah.
So, and I'm just watching, I'm not.
Okay.
Is this a step that you would have to do every time? Or is this just specific to this particular experiment? Or
Typically for pretty much any experiment, you would have this 10-minute period while you're launching a node. We do have a KVM site that Kate mentioned, and those VMs start very fast. Definitely under a minute, I would expect, depending on the size of the image you're launching. But for the bare metal nodes, it will take some time. And you could, have a node that you already have launched and use that for an experiment. But for a reproducibility standpoint, I'm coming into this experiment clean without setting anything up before. This was just something somebody else shared, and so I'll have to set up my own node for it.
Okay, got it.
But I would like to show off this user interface a bit. When you go to it to start, and you can get here under experiment and then chi@UC or any of the other sites. It takes you to an overview, and this looks fairly close to a commercial cloud site that you may have seen, or if you've used OpenStack before, it should look very familiar because it is the OpenStack user interface. It takes you to this overview tab, but I have a compute instances, and this is where VMs would be, or this is where your bare metal instance shows up. So I'm going to actually switch to the tutorial project we're all in, and I see we have 5 of these working. And it looks like these are all building. See, this is my coworker, Adam. He had some error, but I think he was testing out a custom image, and so he's still working on it. I can click on my instance here. I see it has my name in it. It says it's building, and it gives me all this other information. What's the private IP address? I can click on this console tab, which will connect to the serial console of the node. And this will give me some insight into the boot process, which might be interesting. Usually, oh, yeah. And it looks like the boot is not printing anything very interesting at the moment, so that's okay. Oh, there we go. It looks like DHCP is configuring, and this is what we have infrastructure lead on Chameleon, who is much more familiar with how this boot process works, and he tells me that the DHCP process of actually getting all the networking to work on your node is what takes so long. So that'll finish up. Other things of interest here maybe is we have an object store, and you can create a container and use our CLI, or you're able to use S3 compatible tools to upload. We have this share service, which is an NFS, and we have some documentation on how to actually use that. And then we have this reservations tab, which shows the resources you've reserved. I can take this time to also point out under the Learn tab, we have documentation, and it takes you to the welcome, and there's a getting starting page that will kind of be similar and show off all the different things that are going on. And we have various technical pages for each service we provide. So I mentioned we have the object store, so that should be one of these, yeah. And then we have this share system, which is the NFS service.
I was looking around a little bit in the hardware, and I saw that you have the A64FX. Is that the Fugaku supercomputer?
Yeah, okay.
The
The Fugaku.
I work at ARM, so I just noticed.
Fugaku,
Yeah.
what was the question?
Like, how is it that you have like that as
How
a
do we get the Fugaku node?
yeah?
Well,
Exactly.
This is what I was talking about with the Cheetah box kind of stuff. It makes it possible because Chameleon is packaged now. It makes it possible for supercomputing centers regularly get hardware for just testing because they keep abreast of what everybody else is doing. So NCAR, when they added ARM nodes, said this is we were testing those Thunder nodes for our next green supercomputer. Due to pandemic delays, this is not going to happen, right? Because we can't just get enough hardware of that type. But you guys have it, right?
Okay.
This is our testing hub. So when Dunstan Zion, who was director of tech, saw that, said, this is a great idea. I have some Fugaku nodes left over from testing. Have it, and this is a great. This is a thing where everybody wins because from the perspective of the supercomputing centers, if they spend a large allocation of budget on testing hardware, that's starting to raise eyebrows, right? Because you spend so much money, and all it does is testing, and then you're kind of, from a large scale supercomputing center perspective, 8 nodes is nothing,
Yeah.
right? You can't really use it effectively. But if they can add it to Chameleon, that means that they amortize that expense. So since they can now amortize their testing dollars, right, they can have more testing dollars.
Okay.
Right? And our users are delighted. Fugaku nodes, they were very popular when that first out, and it looks like you're interested as well, right? So,
Well, I work at ARM.
okay.
So the instruction set. That,
Okay. Yeah.
So and I don't know how to get access to it, so I was fascinated when I saw it here.
Yeah.
That's cool.
So maybe you guys have some hardware that you want to make available to users as well, right?
For some, we don't produce any hardware at all. We just do the blueprints. So we rely upon other companies,
Okay.
to build actual hardware. So yeah, so does that. Sorry.
Yeah, this is definitely one of the things I think Chameleon does really well is we have a wide array of hardware. We have a great diversity in what we offer. I think this makes it very interesting for people, especially to write experiments that compare against different types of hardware. So we went to the FAST Usenix conference, and there people were very interested in, we have dozens of SSD models that people can compare against it, run benchmarks on. So
yeah, no, that's I'm impressed.
Yeah, well, we're glad you're excited. So, okay, I just refreshed my page here, and it says it's active. It took about 12 minutes, and that's kind of the Cascade Lake R take longer than the Skylake nodes. So due to our Jupyter, you may see that a little pop-up there that says you have to re-authenticate. But if you just click through, it should get you back to where you were. All right, and I see it finally printed out, done, and we're waiting for server to start. So now it's done. All right, next step is to connect it to a floating IP so that we can programmatically control it. So let me run this. Okay, and what this does is it attaches to the floating IP, and now it's trying to connect to port 22 to check for SSH, and I expect this to work. While that's connecting, I'll check out the serial console again, which might be more interesting now that it's actually booted. Yeah. Serial console is not as nice as SSH. It's very useful to have the that working. Okay, it looks like it is still, it says it's active, but it is still booting up. I guess I can show off other things.
I have a logistics question.
Sure.
When you're requesting a project, you're gonna get some kind of limits on what you request, but is it just like the number of things that you can request? It's not like the type of resources.
Yes, so if I go to my projects here, there's this allocation, and right now we have 20,000 SUs, service units, and that basically is a CPU hour. Well, actually, it's a node hour. Yeah. So if that should be quite generous. We typically find, you know, if I am doing single node experiments, I might not ever hit that limit because these are only for 6 months. You must renew. If I'm using a GPU, those we do cost like 2 or 4 units per hour for those. So
they cost you more.
Yeah.
But if you have a good research project, you can always come and ask us for either a recharge, so more rotation, or renew, which is for more than 6 months. This is like I said, some users have been renewing their documents forever instead of asking for new ones. It's like, I still keep working on this one research project that I started 5 years ago.
Yeah. So I'll say for the, I don't think it's ever really an issue for users. You know, if they're using up all 20,000 units, you know, within a month, and they keep asking us every month, we'll notice and we'll.
It happens.
Yeah.
With the GPUs, with heavy usage of GPUs. We keep tabs on this a little bit. That helps us, if nothing else, understand how the system is used. And,
Yeah.
But to your question, we don't place restrictions on what resources you can use. The only restriction is you can't create longer lease than 7 days. If nobody creates a lease after you, right? So nobody makes a reservation when your reservation ends. There's a programmatic way for you to renew your lease, and you could be in principle renewing it indefinitely. If nobody wants that resource, the GPU resource is not going to happen.
Yeah.
That's right.
Okay.
Yeah, like here under the leases in the GUI, there's an update lease button, and I can ask it to prolong my lease. So if I ask it for more than 7 days, actually, I think if I ask it at all right now, it will tell me, you know, you still have a few days on this lease, renew it when it gets closer to the end. And this is just to help people play nice and share the resources we have.
Yeah.
But yeah, as long as people show us that they're doing, you know, good research, we want them to use our resources, you know.
And you're mapping everything in the service unit, so there's no
Yes.
restriction for, you don't have to ever restrict, oh, you can only use CPUs, you can only use this type of GPU.
Yes, we don't really have the, super fine-grained charges that we're doing for people. It's mostly like when they create a lease, we add that to the tracker. And I can click view here. I think it should show me a table of like, yeah, how many things. It says, right, I reserved a floating IP and a host, and that charged us a third of a service unit. Okay, back in the GUI, my serial console finally came up. It printed out some stuff, but I can say, who am I? And I'm in this node. So I think it finally should say that the connection is successful. So the thing I can do is I can copy that IP and open the Jupyter terminal here. And I'll be able to SSH CC the Chameleon Cloud user. And it gets me into that node in this Jupyter environment. You know, I can do like ls CPU, and it should tell me, you know, I'm SSH'd into a pretty powerful CPU. Yeah, 96 threads. And I could do this on my local, you know, any way I want to use SSH, but the way that we like to encourage people to use it is in the programmatic interface so that their work can be replayed. So let me go on to the next step, which is configuring the instance. So it talks about we just provisioned it, but we're just a stock CentOS image. So let me run this next command, which is just running an SSH connection to it. It uploads a setup file, a setup bash script, which runs a package manager. Here, it looks like it's installing as we speak. There's this note here that instead of installing, I could have just took a snapshot of my disk and used that. So that's kind of a different way to think about it. There was the presentation on the snapshotting VMs with old software. And Kate mentioned we have thousands of old user snapshots of, they installed everything they need, saved the disk, and then they can boot to it later. Or I can take this approach where I'm installing it as I need it. And Jupyter helpfully outputs all the things the package manager did, and it says complete. So this next part is, the experiment setup is done, and now I can actually run the experiment. And in this particular experiment, we're going to use stress-ng to load the CPU, and we're going to measure the power consumption of this program. So it says here, there's a script, run experiment, and we're going to run it with different parameters. I can open that before we upload it, and it's basically just calling this stress-ng, and there's this etrace2 tool that's installed that will give us the power output. Let me run it. I think this is going to take a little bit since we're running for 10 seconds. And this is running at various levels of stress, 25%, 50%, 100%. Onto that 100%. And then that'll finish very soon. And once it's done, it tells me, I put my data in this tar file. I can run this cell, which programmatically downloads that and extracts it into the out directory in my Jupyter notebook. So let me open that. It said seconds ago. There's a few runs. So I can open that and see exactly the data. This is just one way to do it. This is a pretty small amount of data for an experiment. 22 samples per run. These. But we could also use the object store or the NFS to share data if we had more. Okay, and this experiment tells us open up the analysis. I can do this, and Jupyter saves the previous analysis. So here is these graphs that Kate had in her presentation from the last time we ran this experiment. But I can run it again, and this is just some Python code to load that data into plots and see what happens. If I look here, I see there's 3 lines, each for a different % load on the CPU. And the y-axis here is the power consumption. So we see, with 25% CPU, use 250 watts. With double, it used 310 watts-ish. And 100% about 350. So this is a fairly simple experiment, but I can run whatever analysis I want on this data. So like the keynote showed on Tuesday, I have access to the raw data. I have access to the same analysis the authors did. I can do whatever I wish to with the code that they used to generate the graphs in the paper. Are there any questions about this or any thoughts so far?
I have a question. So this is an experiment that generates data.
Yes.
What about input data? What about experiments that call on data from somewhere else? Is that, how would that work? Where would the data have to be?
Sure. So one of the inputs that we're using here are like the experiments executable files. And what we do is we upload those to the Chameleon resources that we provisioned. So that is one way to upload. I can run any commands I want on that resource I provisioned and upload data. So for example, we have some machine learning ones, and this is an old one, so it's private at the moment. But I can launch it, and this one downloads data from Kaggle, a Stanford dogs data set. It asks you to, since that's an external service, this notebook says, please give me an API key, and then it automates, logging into the resource, installing Kaggle, downloading the data set, extracting it.
There's a few answers to your question. The main answer is it depends on the experimenter where they want to have their data. And there are two possibilities. One is we have about, roughly speaking, 5 petabytes of global store in Chameleon, and it's configured as object store and also as a shared file system. 5 petabytes is not a lot in this day and age. For computer science experiments, it's actually not too bad because people experiment with less data. So certainly one way to do this is to download the data set to one of those places and either share it or not share it or whatever. The other way that experimenters very often deal with this, there's a system called Globus, and it moves data. It's very good for that. And they used to have an image on Chameleon that they were making available to others. But again, I think it's more relevant to domain sciences than computer sciences, so I'm not sure if they are doing that anymore. But effectively, you could deploy an image with Globus on it, and you could just pull the data as part of your experimental workflow from wherever you keep the data otherwise. It's easy to set up those things because we can give you public IPv4 addresses. So you can, whatever, you can create a service on your instance and it's externally addressable and all sorts of things, right? So it's not like you're sitting behind some firewall and all gets complicated. You can have a public IP address.
Yeah, so to show that example I mentioned here is the notebook a student made for us a few years ago, and they are just running bash commands to download the data set using Kaggle or whatever other tools you would need. So we've also worked with people who use S3, and they can invoke an S3 command to pull in data, or I can show another example in a bit of their research Daniel presented yesterday, which gets it from an edge device. So.
I have a follow-up question on the data thing.
Sure.
I guess storage is cheap, but I'm also thinking about, it seems like the current state of computer science, or this machine learning, is probably drifting quickly towards large language models, and that's, people are training huge amounts of data on huge amounts of data. Do you guys have any concept of like hosting data that the same, like on your object store, that the same people could like point to use as their training? Is that?
Well, so we had that from the beginning. So people were experimenting large data. When we were building Chameleon, the fashion was to download Wikipedia and experiment on that. And this is why we ended up with 5 petabytes of storage. When we built the system, nobody wanted to actually do that. We would love to provide a system like that for sharing data, But I think it's more of a, it's kind of like reproducibility, it's more of a community venture, right? You know, the community has to organize behind that. And, you know, whatever the current version is, whether it's Wikipedia or whatever other data set, we love to host it. I'm reasonably sure that storage would not be a problem. I'm saying we're into HPC data centers, especially parks, tons of storage that they could probably repurpose or temporarily add to Chameleon for that purpose. So, you know, if there is a need, if there is an initiative like that, we can throw resources on it, but we can't organize the community. I mean, we're trying to get the community behind it because it's super important across the board. And we have a special project for that, right? As infrastructure providers, it's not something we can do.
I see.
I feel like it's a tricky question.
If you like,
It's a tricky problem because there is in the data community and we're in a kind of a trend toward data visiting. So you're not downloading it, but you're bringing your compute to the data, and that's important, especially with secure data. And you know, making that connection between the analysis and the computing resources that you need and the data is evolving. I don't think we live anymore in the world where you download everything and you just do it in your own.
Yes.
Not possible.
I completely agree with this. I think the problem is much more visible in domain sciences though than in computer science. Computer science, it really is. I mean, even, you know, Torsten, he works on large scale problems, but he's talking about 1 million data points. That's not that much data. I mean, it depends on how big your data point is, right? But it's not a huge amount. So in computer science, you know, a vast majority of experiments, I would say, operate on relatively small data sets. It would be interesting, it's super interesting to do what you say. And I definitely, I'd love to build infrastructure for that, right? But again, it's the community, it would have to be community driven, right? The community would have to say, all right, we've got some data sets that we'd like to have. Where can we put it? You know, I can find you a few petabytes. I can definitely put it on a few petabytes. If you need more than that, I can find you more than that. After that, we're writing a proposal and we're saying we need this data-oriented computer science test bed, right? That is designed differently, but it's a bit of a chicken and egg problem, right? What should come first? Well, we have a little bit of a chicken, right? So
Yeah.
you know, you just need to lay some eggs and then.
Or you know, you did mention Globus, and this is something people need. We'd love to work with someone like them who to integrate it more with and make it easier for researchers to.
But yeah, as she was just pointing out, we can't. I mean, we're increasingly limited in how much we move data, right?
Yeah.
And the current data and computation ratio favors moving computation, I would say.
Yeah, you mentioned S3, like you have support for some S3 connections, because I think like Common Crawl, which is a big text data set, like terabytes and terabytes of data, is hosted on S3.
Okay.
So we have a part of our storage in Clone is called the Swift. It's object store. It's very similar to S3. But we also have this one Jupyter notebook from Trovi from a collaborator from RANC who was running experiments over Chameleon and commercial clouds. And there's this NSF-funded project called Cloud1, which will benefit from the use of commercial clouds. So, and you know, of course, download is one of those things you have to pay for, right? Probably if you took his notebook, you could adapt it, or you could, you know, see specifically how to run the commercial cloud in Chameleon-based data set, and then the Cloud5 project. I don't suggest that you pay for all of this yourself,
Yeah.
especially if we're talking about actually the sense.
Yeah, yeah. I do not want to train a large language model, just to be clear.
Yeah.
But I am curious about how
Yeah.
the platform.
Yeah, maybe it would be good to point out on our page, there's about and papers, and this one down here, Overcast, I believe is what
Yeah,
you're
yeah.
referring to.
Mhm. So that Jupyter Notebook is just a reproducible overcast.
Okay, and then I'd also like to point out the used in research tab, which shows all the things people have done on Chameleon, and this is the 600. How many citations are there?
613 papers.
Yeah, so
Last counting, but it was like 2 months ago.
yeah, there's a lot here that you know, we're happy to show off. So.
So I just understand, so those papers there, you can reproduce in Chameleon, more or less. Or have they used
They
Chameleon?
use us.
They use
They mentioned that they use us.
Yeah, they don't include our papers. Our papers are under a different tab.
Yeah.
There's something else. There are papers about the system that we have done in our group, right? These are papers from our users whom we, for the most part, you know, we don't know them personally.
Okay, I see.
This is a thing we would like to do, though, is some of these were involved in reproducibility initiatives at the conferences they were submitted at. And they very well likely did not use Trovi yet. And so they live elsewhere, but we would like to, you know, highlight which of these have that.
Maybe create another page of, you know, reproducible papers from Chameleon, something like that, but that's.
So maybe I can talk just a bit more about the other things we have on to show off what else is on Trovi at the moment. I mentioned we worked with some storage researchers at FAST, and they have created this, oops, let me go back, this simple benchmark file system. And like the power management one, this is what we like to call an experiment pattern, in that it isn't reproducing the results of the paper at the moment, but we hope that it can lead you into something you can copy and paste to run your experiment or similar. So I was talking to them and they shared, you know, here at this paper, at this conference, they just need something to run these standard benchmarks. And they talk about there's this commodity tool, FIO, which exercises storage IO in various ways. So this group has created this experiment that you can, like what we just did with the power management, you click play and it hopefully works without errors. You don't have to really interact with it. Let me see. Yeah, I think it is here. But if I go to the analysis, we can see they've collected some sample data from these commodity benchmark tools under an Linux file system. And if I'm a storage researcher, maybe I want to take this. I can use the same exact experiment setup in the experiment workflow, but maybe I need to add a step to use my novel file system or something and compare the results. So these experiment patterns are a starting point. They're things you can copy and paste, fill in the details, and turn it into a work. And the next one I would like to show off in this vein is the one Daniel presented on yesterday, the multi-experiment edge to cloud workflow. AOPS was the name. And he mentions here this is based on an edge to cloud experiment pattern. And he has extended this to make it work with other test beds, showing that you can run the same work on these various environments, not just Chameleon. And I'll just open it up and show off. He has some nice features. So I think under here, the vision is we have these edge devices and they submit data to the cloud over some broker. And on that cloud, we can process and see what results we get. And this is where our Chiat Edge platform comes in. So he reserves Raspberry Pis, and instead of actually having these in the savannah, taking photos of animals, it downloads a data set and just sends that. But you can imagine getting that data from a camera rather than this pre-existing data set. And then he also shows it on the FIT IoT Lab in Grid 5000. So, and then maybe I can mention, so this is an experiment that you can reproduce now with, there's a link here. The other way to get to these is on the experiment Trovi page. You can just search. So I can search for that multi-platform edge to cloud experiments. And we're also tagging these. So people have assigned reproducible research to their artifacts that are trying to reproduce something. There, Daniel's experiment comes up as the first one. And I'd like to point out one more at the moment, this reproducing Tacotron 2 qualitative claims. So this was made by one of Pareto Fund's students, Priyanka and Chandra. They are very familiar with the Colab environment, which I don't know if people here use at all, but it's Google's way to package their notebooks. And they have the advantage of being Google, they're very large, and so people use that, and especially machine learning people like to, you know, share a notebook easily with that. And in their environment, you can run it, provided you have access to the GPU requirements that these notebooks require. So if I launch it, and I think I launched it ahead of time. Oops, it timed out. Let me relaunch it. Their notebook here has a citation. And what they're interested in is running this researcher's machine learning model and comparing what the output is to what they say it is. So this may take a second, but I wanted to point out that this is a little different than what we saw earlier, where I'm using Jupyter to orchestrate the resources in a Chameleon server. Now I'm using Jupyter to orchestrate the resources in the Chameleon server in order to run a Colab runtime. And this is something, it's a service you can connect to from your Colab notebook to add resources to it. So Colab, you can either use like Google Cloud as a backend, or with this method, you can use Chameleon resources as a backend, rather than if you don't have, you know, Google credit that you get through your institution or something. So yeah, trying to switch to the tab, but Zoom is blocking me.
Colab's a runtime, so is it a full container, or?
So Colab is, yeah, actually, and let me download this because
I can look at myself and just ask how it's with it.
So let me actually open it because I think I didn't scale up our JupyterHub in anticipation of this, of me launching a bunch. So it's slow right now, but this is the notebook I believe that they're using. Yes. And it does have a web environment here, but when I want to go run it, it'll ask me to connect to something.
Okay.
And I can either have it run on my laptop, but it's going to be very hot, use all my battery, and I don't really have a great GPU here. So it's going to be slow. I can connect it to a Google Cloud VM, or I can do a hosted runtime. And here, it'll ask me, I think, to input a URL.
Actually, around a notebook.
Yeah, so actually it is this local runtime backend. So it's installing the server on Chameleon's resources so I can run this notebook on these powerful nodes.
Nice. Okay.
And what I'd like to, you know, point out that is a really cool way to use things people have already done. And I was kind of going to end this part by and saying we have all of these various experiment patterns that show off different parts of Chameleon, and I would be happy to show more. We have some of these interesting things to reproduce, and these can all be great ways to get started packaging an experiment with Chameleon. But in terms of, you know, I want to create an experiment, maybe I don't have one of my own. What can I do? People were talking about papers with code. You know, you can take these things people have shared and make it so they run with one click on Chameleon. Or this idea of connecting a Colab runtime. I can search GitHub for Google Colab repositories and find interesting experiments that people have already written in Jupyter notebooks and launch these.
So
yes,
what
I
I
think,
suggest that we take.
yes, I think now maybe we can take a break.
Till maybe 11, and really the rest of the session, what we want to suggest is that we've got this reproducible research in Trovi. If you want to pick up an experiment and try to reproduce it, and tell us what works, what doesn't work, what's hard, what's not hard, what we should improve, that would be fantastic. But also, just see if this vision of picking up an experiment from a hub and playing with it, if that works for you. The other possibility is package your own experiment, right? We're here, we can help, whether it's methodology suggestions or how to use Chameleon or anything like that. A note about those experiment patterns, they're not so much about different features of Chameleon, but they are designed to be, so if you can think of experiment as you set up an experimental environment, so you allocate resources, configure them, and so on. The second stage being you actually run an experiment. So everything is set up for your experiment. You just run your benchmark or whatever it is you're running. The third stage is data analysis. These experiment patterns represent that first stage. You set up an experiment that does in a specific area. Right, so you can treat them as maybe half of an experiment already there, and most of them also have those benchmarks in it. So this FIO benchmark, so not just sets up the storage experiment for you, but also runs the benchmark and does some data analysis. It's not necessarily connected to a specific paper because it's been developed to be kind of a cut and paste experiment pattern to help people get started. Writing their experiments or different ones. So I would say maybe a little break, 5 minutes, come back. It's free form. We'll hear about that you can reproduce experiments and do package your Such a disappointment. You don't have hard food today.
I know. Really fun importance to take out of this. And that's rough, that's so that's one. So that's like reproducibility. This is all. but they have to scale. So if someone really wants to train on all that, they're not gonna do that. Well, this is for foreseeable future. So, or am I wrong in that? So we collaborated a lot with our own operation. It's an open source, they only do open source. Everything they use, they build from they but and then they use pay that. Like our base into like right now we're running to have certain machines so accessibility that I saw. Yeah, I could get a little bit. Yeah, well, I can't say for unless you have like an incentive or something. So that's this is.
You have to be very flexible. You know, and I definitely took effort to get those doctors. Yeah, people want to.
That's what we say.
Yeah.
And then in the cloud. So if you can do hardware include that in the cloud.
Yeah, and stuff is kind of new. So don't provide us a level of just a little bit of voices up. Yeah, it's that.
So that works for certain aspects, but if you have like some of the artists, it's environmental. You can run it. Yeah. So I can introduce that. I can show you that. So
we do. But one option is role of VM as a device, connect to our service and manage where we haven't used yet.
spoilers and all this. That bicycle parents. My bicycle parents. That's why so it's never I went to the A-bar, that's why but they can say A-bar together is what's hard. But it's a beautiful dog. It's fun. there's a bike path that goes. This is a person I'm exploring by foot / bicycle up here. So over here and squirrels. So not too exciting.
Is that a remarkable tab?
Yeah,
Do you like it?
I do. I even got the new keyboard because of how much it's been kind of transformative. I got it as a gift from a friend because he didn't like it. So I started out a leg up, like didn't buy into it, so I didn't have like too much invested. But I left this is a different path in my brain, and part of this is because a lot of people came up with using keyboards to do stuff, but I was in journalism and creative writing. And so in high school, I was doing journalism and in the 80s, and I'm doing desktop publishing as best as we literally were printing and cutting and pasting onto paper, which is the printer stuff. But I was always very much in the realm of, I'm an editor and a writer. So when I get on the keyboard, the flow is very different, which is actually it's an interesting aspect of my, it's a practice for me in open source to always be trying to pull writing out as quick as possible and not to be studying kind of trying to perfect it. But this seems to come this goes back to an age, my brain neural pathways before I was on the keyboard. And so, as a writing pathway for writing all kinds of things, notes and stuff, it's turned out to be really fantastic. And then to be able to sketch an idea based on a conversation and then send it to you and then you can talk it back and forth until it's correct and then have that converted and then spend the effort. Because if I start trying to do a graphic from our conversation on a program on here, then I will be down by the pixels, moving things around and never get the big picture down. Like there's this weird thing about it, like this lets me do the big picture. But now the keyboard is the new, let's react like that.
That's cool.
And it's pretty, it's not even, it doesn't need charging, doesn't need anything else. It's part of the folio. And the dynamic is, it gives you a place you can put type text directly into, if I was to start.
Yeah.
And it's really, and they've got fonts, it's got a different range and it's just very basic course. And so there's no web browser or anything else. So I carry this with me in my lightweight thing and I sit down at a cafe and I'm not, or in a park or something, and I'm not being distracted with these other things. And I'm still learning how to use it. I think I'll the control key down, special thing, right? 2, 3, 4, 5. Yeah, so this is basically all the possible things you can do editing wise, but the standard pieces are there in terms of Control Shift and arrows to select and move and copy and paste text and to move around within the document. So all of that memory is built in, undo and redo, and and then some other Control W and then search, right? And so then you can mix within a single document. Right. And so it's kind of, and you can see that they're sort of trying to build up to this whole thing for a while. That's how the whole thing comes together. And they've got a cloud service that then backing up into, and I don't know if I may actually be, back down this up. Very highly secure system, but Usually, yeah, I don't think I have a. Try to configure this one. Yeah, I'm sorry, it's actually a hard time getting it.
Oh,
The usual going.
So maybe I could also introduce just quickly. So people are free to explore any of this. We'd love to talk about it. If anyone has any questions, how these things actually like get packaged and made. So there are a few options here. So if I, from the main Chameleon website, there's the Internet Jupyter interface, and that brings you to our hub, and hopefully it loads great. And here is it's kind of like a VM. You know, I have my own little environment with a file system. I can get a terminal, I can install libraries or whatever software I want. I can create these directories, and we have an interface to package these artifacts. So I have this directory here called AlexNet with some, I was taking that work a student did, I mentioned earlier, and trying to update it because it's been a few years. So if I want to actually, I haven't 100% finished it, but for the sake of example, I can show how it works. So I can right click it and do package as artifact. And we have some guidelines sort of what should happen, or what, you know, this ideally should be. We have a link to our documentation, which explains everything in more details and tells you everything you can do. But it'll ask you for some metadata. So I'll say, this is my AlexNet demo. A short description. This is a demo artifact. It's still a work in progress, but that's okay. I can give it a bit of a longer description. This artifact reproduces, and then, you know, explain in detail what people might be, why they should be interested in this. I can make it private or public. I'll just leave it private for now, just to not confuse anyone who's looking at it, maybe, since it doesn't exactly work fully. I can add authors here. I'll just add myself as the only one. And then I can upload. It basically just zips the files I have, uploads them, and then it says it was successfully packaged. I can click that link there, and it'll take me to my artifact. There are a few more options here. I can, since I'm the owner, I have this share button, and there's some more options. I can publish it to Zenodo to get a DOI. There's a private link that, since this artifact is private, I can share this link with people to see it. And then this third section here is enabling daypass. So to do that, it's called reproducibility requests here. And Kate was talking about it, but the idea is somebody who has never used Chameleon before. So let me go back here to the bare metal experiment pattern. Somebody who's never used Chameleon before, they won't see this launch button because we haven't given them an allocation, but they may be interested in still running your experiment. So instead you can enable this request daypass button, and it'll ask them to enter some details and, you know, leave a comment so it doesn't seem like it's spam. And this will go to the author of that artifact and actually I think it goes to their PI. So the author may be a PI, or the author can delegate someone else to receive these emails, or the PI can delegate someone else if they're busy, but we're trying to preserve some chain of responsibility. And they'll see that request, they can click approve, and in this case, I'm the requester. I would get an email back saying you were approved for a day pass. Click this link to join a Chameleon allocation for X number of hours. So that is the daypass idea.
And the daypass does not count against their.
Yes, it's its own separate allocation. So this project, if I enable daypass for it, this artifact, it'll give me 1,000 SU allocation, just making sure people don't mine a ton of Bitcoin in a few hours.
Yeah.
And yeah, it'll be separate. And we are hoping people use this more. So if we have to impose more limits, maybe we will in the future. But for now, we just want to encourage.
Yeah, so the daypass is a pilot at this point, and which means that we don't really understand what the pitfalls are. Generally speaking, Chameleon is organized by delegating responsibility. So when you get a project and Chameleon SPI, you're responsible for the good behavior of the people on your project, right? So you're responsible for making sure that nobody mines Bitcoin, right? Or allow, configures their instances in such a way that the configuration results in somebody getting hacked and somebody mining Bitcoin, right? So this one is another example of that. As the owner of the daypass location, you give out access to people who you feel are more or less legit, right? If we find somebody who asks for daypass allocation and somehow everybody who tries to reproduce their experiment ends up mining Bitcoin, I'd say that would raise a few eyebrows.
Yeah, and one thing, that might help is if you're a student, or maybe you mentioned, I saw your presentation at ACM Rep, and I saw your paper, we're trying to also foster the community there, there's also this edit artifact screen, which kind of does as you would expect. You can update your metadata, add other people who are able to collaborate on this artifact and upload new versions. Back in my Jupyter environment.
Yeah, so I have a question again.
Okay.
If you're updating, when you have a DOI, it's associated with the artifact.
Yes.
But not the metadata. So if I go and update the metadata, it's not going to change the DOI. Are you doing like versioning on?
We do versioning on the artifact contents, not the description and title, I believe. So yeah, if I now go back to my Jupyter and there's a way to edit it, actually, there should be a way to create a new artifact version. I think let me close that.
I mean, since you said it's integrated with Zenodo, right?
Yes, yeah. So you can, now that I have an artifact version, I actually think if I go under share, it will let me request a DOI.
But for
this specific version that I just uploaded.
Oh,
so the Jupyter notebook files that I uploaded.
So it'll use Zenodo's DOI thing where there's like a DOI for the entire artifact, and then there's a DOI for each version of the artifact.
Yes, I think these files are archived into a zip, and that's what's uploaded to Zenodo.
So this is actually, this hints at a very interesting problem that we had in, I co-founded a journal that publishes software called Software X. And it was always the kind of question also, if somebody published software, if they make a new version, is that a new publication? Right? And the solution, which is essentially a very similar question to what you asked me, right? And the answer to your question was, well, it depends, right? If it's a minor version, it's a minor improvement to the software, it doesn't constitute a new result, right? Then they should just create a new version of the software and just keep creating new versions of the software. If they have a new major you could say major feature that represents a new result, it's a significant new functionality of the software that extends it as a scientific instrument to support something completely different, then it counts as a new result, right? And it could be published again. And in the same vein here, if your experiment changes, so let's say you have the same experimental pattern, but you're running now a completely new experiment. You know, ChatGPT-3 versus ChatGPT-4, significant difference, I would say, right? So
Yeah.
I would say those are two different results, right? But yet the same root in a sense.
I see. Okay.
Yeah, I can mention there's also, now that I've created this artifact, there's a create a new artifact version button. And if I upload, it'll show up with a new version on the side there. So let me go back to the main page and I can see that historic version.
Okay. Yeah.
And then I can also point out just a few more things. We also, some people don't necessarily prefer to work in this interface and they keep their notebooks in a Git repository, for example. So one thing I can do is I can take that Git link and I think if I do edit, I can create new versions directly from Git. There's also, you can originate the artifact from Git as well. There's another button, but I can add that Git URL. And then if I tagged my commits, it'll let me pick which one, you know, version 1.0 and clone it from Git in the future. And then I think the last thing I want to mention is we also track metrics in Trovi. So here there's this bare metal experiment pattern and it says there's 285 people have clicked the launch button and launched this. And recently, so these metrics, these next ones look a little smaller, but these are more recent. We're tracking individual number of people who have clicked that. And we're also tracking people who've executed cells in this notebook. And so I think there is some potential to analyze Jupyter usage a bit more here. But for now, we can help measure the impact of these artifacts better. And I think that is basically all the features Kate introduced earlier. So if, again, there's these slides with interesting things to explore, or if people may have interesting ideas of their own experiments, we'd love to help talk to you and make it possible, or we'd love also any feedback on these tools.
When you've done, like I'm running the bare metal experiment pattern thing, is there a way to say, you know, I know for sure I'm done, I'm going to release these resources?
Yes, I did notice that we should create a new version because that one does not have a delete cell at the end. Yes. So the fact that you have to lease your resources, when your lease ends, it is automatically cleaned up. So a good practice is, you know, set that for a few hours. If you, this bare metal experiment pattern, you can run in half an hour, including the setup time. So that lease could only be half an hour, or to be generous, it can be 2 or 3 hours. And that should minimize impact on other people who want those resources. But yes, we do also have this Python interface with ways to delete your lease, just to be explicit about it. Yeah, and most of our other experiment patterns, we try to include that step explicitly.
One note, Mark and I will have to leave at 11:45, a couple of minutes before then, to run to the airport. So we're going to be here for another 20 minutes.
Yeah, and maybe on that, if you want to get in contact with us, we have, if you're logged in, there's this help desk button. And this is like what our users report as the #1 feature, and it goes directly to us. Even Kate sees all of these tickets every week. We review them and discuss what problems people are having and what we can do as we're planning more features and improvements to the testbed, what people want.
It's very useful for people with applicants because we really review it and we always learn, like every single week, we learn that, people expect the system to behave differently, for example, or somebody's disappointed because something that, they wanted to have this in there or something like that. And it makes sense to submit the tickets, not just when things don't work, but when you have like methodology questions or comments for improvement and things like that.
And then the other way we engage with our users is we have a blog, and we are very active on it. We publish, we love to feature experiments users have run on our resources. And if people, have interesting tools that they're working with and that can potentially help other people, we'd love to show that off. So this is our most recent one, talking about how a student, Jacob, packaged, or how he created this tool to really improve file transfers. Also, communicate about changes we're making to the testbed every month, and tips and tricks on, how you can use all of the services we have. So, we talked about we have all these sites. Maybe it's interesting to you to make sure your experiment can run at any Chameleon sites. So we're very federated in the sense that we're not, I think AWS is similar, where some things don't automatically transfer between sites. And Chameleon, you can do it, and this is how.
So that might be, I've got a topic that I'm curious about that's a little bit, but it's back to what I was talking with you about at lunch. I think it was lunch yesterday. Okay. Yeah. So, and so I think kind of I'll recap for Kate and the rest of the room, but just curious about we're starting to get to being service providers for research, right? Now I have a relationship with a completely different research cloud that's doing similar and different things, right? And which is not uncommon in the research space. I mean, that's part of spawning things is great, but there's also this dynamic that we're getting into where the cost of the underlying cloud platform becomes this limitation that everybody's running into. Like you were telling me a story yesterday about power outage dynamics, and I was telling the story of a Ron Krieger told me that in the mass open cloud, they actually turn off. They have a planned power outage in August of every year of 4 days where they do systems work. And he told me it's because he wanted the researchers to not think of this environment as a 24/7, 365, because it was so reliable that people were starting to treat it like it was a free AWS environment that would just keep going. And so there's these really interesting dynamics that all of us are running across at these levels. And then there's a point of where the Chameleon sites kind of thing is trying to address or I would presume that, how are you going to scale beyond just the resources that are accessible via the organizations you have relationships with now? How do you, what are there's connecting at the funding level, and there's also connecting at the technical and the open collaborations, the open source doer levels. And right now we have those capabilities. We could be, I mean, that was my first thought here, was like, oh, I can be using and taking advantage of the daypass to get some of my friends over at Mass Open Cloud to come over and take a look and see what you're doing and try some things back and forth, really, and not just people who are like the lead data scientists or things like that, folks who really would be curious to see how things are coming. But the other thought that I'm wondering about is there starting to be a critical mass, and is this especially in anticipation of what the federal funding might be towards a nationwide effort? And if there's something national that's going to be coming or that's going to be happening, and there's some indications that maybe there is, right? Then having us begin to get together on the grassroots level and start to have those grass tips conversations between all the PIs and everyone in the different, well, I mean, So that's what I'm curious about. It's like, is this the time for the starting of that? And is there energy for that? And what's the venue or what's the dynamic to do?
Well, I think that this is something that to a large extent has been going on for a while. So we're talking about, so first of all, people are talking about the national
Yes, okay.
I think this is going to be a cloud. I think it's partly depends on what the definition of cloud is, right?
So did you have an error when you ran the
For
session?
supercomputing people, a cloud looks very different, for example, than to me, right?
Right,
Because for them, it's just this.
The next one is where I would.
I think that clouds like Chameleon, there's a spectrum. Clouds like Chameleon is of course the cloud web project, there's Fabric, which I would argue is a cloud as well, in the sense that it's got programmable interfaces, right? So it's sort of network cloud. You know, there are sort of more esoteric clouds, just that there are more, there's actually a surprising number of sort of more based on clouds, like Jitstream 2. Every institution seems to have clouds, cloud deployments like that, right? So it's quite interesting. It gives access, and then and then you go progressively towards sort of more streamlined and more production ready.
Kind of the
Sorry,
most basic
so when
one.
you say
A lot of people.
what does cloud mean to you?
And I tend to have an expansive viewpoint of it in terms of it being, what I'm willing to use the cloud in the conversation for somebody to, well, let me go back from this. I mean, I'm thinking about research clouds in particular that would be underlying infrastructure, providing infrastructure as a service. Open infrastructure is where my background and practice would be. So open in the sense of open source, open design, like everything but the secrets are visible. And so even being able to get the telemetry down to the bare metal, and not just like you can just put a tap into and get to pull it out if you want to. There's going to obviously the organization around needs to do some work to make sure that the privacy is taken care of, anonymity is happening, certain things are happening, but then being able to provide that sort of data. Because ultimately, I think that and maybe it's just because it's my background in platforms, but I just think of this as like on the bottom line, there's always going to be metal, there's always going to be an operating system, there's always going to be a thing that's running applications and something orchestrating that, and it could happen at layers. And so even like the high performance computing, I'm sure there are still plenty of ones where people are orchestrating their own, they've got their own custom code, but the future, what's the future that's going to be? And and I guess it depends on your performance character. Anyway, I don't want to get too far down that. I think there's a lot of good rabbit holes in there that are interesting, but I do wonder what I'm thinking about is must be at the layer that's probably at the service and orchestration layer, something that, I mean, I can almost imagine something that's sort of lightweight that is what's the lightest way to connect different cloud resources to each other, so we can be sharing, we can be bursting to each other, or we can be connected together in a way in like a national emergency that you want to pull together all of these competing resources for doing vaccine research and whatever.
Well, 99% of that is going to be driven by production science. And their needs are not
Typical cases that they don't, but
really don't support integrated.
really do have people who
Right?
need that, and we let them.
But I've worked with a lot of application scientists in production.
Yeah, Kate knows. She started it.
I'm friends with most of the supercomputing center directors right now.
That's how Daniel was
So,
working on.
I have some understanding of the community.
Because they've been around longer, so I think they used to use some of this because Kate was collaborators with
Tend to be very different, and
At this point, I don't
they
think we're like
would see
tied to them.
some deep instrumentation and things like that as
Have connections.
as destruction.
Yeah, because
I mean, a lot of I would say innovative features, unless you can speak, right? So for example, energy-based scheduling and management, the GPUs now, my energy costs have tripled.
Yeah, I think you have
And this is what we're talking about.
artifact Daniel made and compare between the two. That
And
might be
if you understand that equation, if you understand the costs of running a large data center, you might be able to convince people, it's like, no, if we do this, the sun and the wind and the thing, it might actually be a good thing. And there is a way to do it, there are actually mechanisms to do it.
So I think steps of like
Something
what
like that
commands you need to
might
run
be possible to make a case for.
allocate the
Just,
resources,
I would say the time is.
create your node
Yeah.
You have to.
may be different, but once you have,
The dynamics
connection
of
to
community.
the resources,
What they would,
hopefully,
what they would look for, I think they're good business case, right? They give you this, you give us that.
I would expect.
It's,
So of the truck.
the 99%.
Yeah, so
is,
another thing is
it's
we
a
have some
user
things that
scale.
work out, like
Needs a dynamic, so it's gonna work out
multi-cloud artifact would do this, or we have another one for networking.
Favors
And
right
this
now,
person
they don't count.
works with Fabric.
So if you can
You know,
capture a
he
large
has,
data sets.
when you go to set up, you can either set it up on Chameleon or Fabric. And you're running the
Large data
same
sets, so,
thing, but
you know, it's a lot
yeah,
of.
the interface at the start
platform
to
that
provision your resources.
you know, with stuff dedicated. Or two, or three, right? So, I think that this kind of national AI resource, something like that, getting that space.
We have some
People who can demonstrate their own work in those communities and understand their needs and can solve
we don't
them
have
in the
limits
simplest
as far as I know.
most effective way possible, because both those communities and the sponsors
at UC, storage in general,
either takes
people
over
aren't
money
using
or,
it to the point
takes
where
over.
we're afraid.
No, this is interesting to that point.
So I think
Yeah, well, I don't know which one.
So,
we could make,
so
I think that would work. And if we do have limits, we
you know,
probably
I don't
could, right?
know if there is room there for being very fast, but the testbed space, you know, like Chameleon or
That's, I mean, that's, and I think I think the New England Research Cloud and its production for researchers and students in New England, right, at that level. So they consider themselves a research cloud and are not providing a service level agreement and are not acting in any of that kind of mode. But I'm curious about the. Well, okay, yeah, no, that makes a lot of sense what you're saying, because it really has to do with the layers and which.
Yeah. I do think we should have very high bandwidth connections, especially on.
Because I think I'm realizing that there's another layer in which we're all getting together around the open source tooling, and that's another, which is a middle place that as we standardize on things like Jupyter notebooks and using, you know, and when if we're careful about services that we use, so we're whether it's a GitHub or a collab or anything like that, what you know,
But I think he might have been using
are replaceable, so that we're not caught out of those if and when those go away
I would expect
or become controlled.
to be able to do similar with our object store located database. I'm not aware of the number.
Makes sense to just use it and not bring that back. And I would say.
Some of our, we have the various networking adapters, and I'm sure
Everyone wants to.
it might be buried in our blog of like how fast people transfer.
Yeah.
I think that effort eventually becomes.
Yeah.
That's
That's a good way to put it.
Oh, that was it.
I haven't started yet, so,
Oh, okay.
so I just wanted to show you this.
That is what,
Yeah.
you know.
So here you have your main computer services, really high performance. So that would be your, like,
In a
basic,
way.
graphics or like universe or sort of that's like.
So, and it, you know, I totally.
You're on certain aspects, computes around that, and then media services like for hardware.
Mine's still provisioning.
Fix it somehow.
So they have a higher level of services. So.
And another area, and then collaborating on practices and principles and ways we do things, so that can also make a difference. Are you familiar with iScale that just got announced out of? It's essentially the next iteration after Mass Open Cloud and New England Research out i-scale.org.
So did you have to just like
One set for this computer.
Ron Krieger and Peter designers.
Okay.
Yeah, so they.
I bring this up as like storage with the TUM and some other
Is this it?
universities.
Yes, this is it.
Real-time applications, because that's the science. And that's So the Cortex R is one of these that HLD certifiable marker.
So here in Iran that started the MOC Alliance, which what used to be called Master in Cloud. And so it's all that.
Some other things.
So,
Yeah.
How much money is this?
This conversation, and I can share all these.
That's a good question because they haven't, I think that they were just putting,
Or
Mm.
in Chameleon. So you can access that, so then you
how
can.
much are they asking for? How much are they getting? Who
No,
are they
how
partnering
much
with?
did they get for this census? Did they
That's a
get
good
it?
question.
I don't know all the details.
That is what, well, because that is what,
And there is a open source,
I think that they both, I think that they were working on a new, we're just actually,
so.
closing in,
Yeah, this would be,
was it in June?
it sounds kind of.
For the next level of funding. So I'm not sure if this was funding that gave, that's the board number.
If they don't have access to it.
Yeah, exactly.
Since it's probably being funded out of the MOC Alliance right now. And they're seeking to get more funding just for it.
Jace.
Yeah, I think it's what. Yes, it is, right? And that's been, I mean, that's been how part of how they grew the Mass Open Cloud, because one of the, I mean, even that right there, it was the Massachusetts Association, there's the Commonwealth of Massachusetts is like very directly involved in helping things that are running out of the Massachusetts Green High Performance Communication Center. And so it has this whole cross connection, but the Commonwealth is interested in connecting with everybody broader, but they're doing it in a long term and a policy angle and stuff. And I think they're also hoping that by all of this grassroots things happening in the open space, that we will all be making kinds of under one and research group to research group connections, and then the clouds to clouds. So.
I know Peter and
Are they really that high?
Well, I guess I just know that.
I was fortunate to be at.
You can run it.
Yeah, I was fortunate to get to I got to go to the one of the last things I did at Red Hat actually was go out to the workshop where this was all announced. I was
Just send an email to
the MOC Alliance representative for a project that I don't know if Red Hat's funding anymore because I'm not there when they wanted, and it's this whole it's the whole dynamic of the world of it's fun when moving around and open source is interesting because almost like your research can be, you take
Also, like,
a certain amount of the work with you where you go, and the reputation and the stuff, you sometimes keep doing the same work for somebody else, and so I never know what this is going to turn out to be.
It's off the shelf components. So that.
But I appreciate going through this was great to look at. And part of that shop was get to sit down with their facilitators whose job it is to work with the researchers and bring them up either in open space.
So there's another test bed, Aura.
Help them containerize their things or help them, get the programs going and then support them as they're going forth and really how they're doing that on a social kind of the culture change angle as well as the very practical hands on how it's all going on. So I have some folks help me, like I said, and not just to talk to the show through because I think that's interesting to see how
They probably actually know what I'm doing.
Independent site to manage the control of maybe.
That's the same thing. Yeah.
Use the same stack.
Yeah. Oh, yes. Exactly. Yes. Yeah. The OCT was that's part of that.
Aura.
Yeah, there will be
So the open code test bed was.
The architecture is
We moved this way.
Really? Wow.
Yeah, let me take a look because I
You're showing. I have a coworker who has worked with them closer.
So open code test bed.
Other groups do.
Was that they.
To use our package stack. Yeah, Mark Powers at Chicago guy. And I can forward that. .edu.
they do they've got all the FPGA and I think they're running it through the New England. they had to put a lot of effort into getting front setting going for the, so that now got all the single sign on all for the environment, everyone that, but that was like a year's worth of time of integrating that into OpenStack and OpenShift. And I think that's probably what happened with the Open Cloud testbed was that focus. So, but yes, I will, that's one actually I can follow up on because I just met those folks. And I will for certain. Yeah, something's going on.
Okay, cool. So just send all these things here.
Yeah, it's just say your time is up, and I will be in contact with Mark.
Sure.
I just thought about this.
Well,
It was a pleasure meeting you. Thank you for coming out.
Yeah, we certainly send you stuff.
I'll look you all up next time I'm in Chicago and come out and see things.
Because I don't like, I can ship your hardware.
Well,
However,
another
I know
option
that-
is sending you our software.
Yeah.
And so,
And yes, but so ideally to be in the university where so like we could you could get access to this and your applications on it and such.
Yeah.
But so I can't commit to it right now, but I think this would be a really cool thing.
Yeah, if you send it to us, we would be happy to talk about it.
Yes. Okay. Right. Yeah. Thanks so much for the presentation.
Right, for everybody online, unfortunately, Mark and I have to leave.
Yeah, that's really
I
cool.
think a couple of the people, two of those people are in the room. I think only one person's not in the room.
Yeah.
There were more people in earlier.
Yes, we had like 11.
Would drop my conversation. Distracting Kate, so.
Sunglasses, that would be terrible.
Safe travels.
Yeah, safe journeys. Goodbye.
Bye.
We're probably ready in about 15 minutes, but we do have some snacks still outside.
Oh, yeah.
Which you've discovered apparently, yeah. Just so you know, whenever you're ready for going down to lunch, we're still setting up, but it is. You go down to the second floor,
Yeah.
take the elevator down or walk down. It's like on the outside, just at the beginning of the building,
Okay.
that just so you can walk along the pathway, you'll see.
Yeah, I'm just wrapping up an email
Oh, yeah,
to Keahey and Mark.
Yeah, no, right, I'm
Did you
literally.
say what's outside?
It's outside, yeah.
Oh, wonderful.
And is this still on? Oh, I gotta change. All right, whoever's on, if anybody's still online, we're actually using a different Zoom room.
I'm Casper.
Oh, you're
yeah,
Casper.
So I'll log off.
I should have known that, sorry. Oh, no, no worries. I'm just ending it, so.